Okay, so we're looking at average rate of change, which is something that you've seen in the past, and we're going to use that to talk about instantaneous rate of change, which I just talked about with the difference quotient is going to be part of us helping us find the derivative of a function. And so what is a derivative? You might be thinking, if you don't know, or maybe you haven't taken the course before. You know, with lines, we could always find the slope, right? If this was a line and it was increasing, right? We could see it's increasing and we could find the slope anywhere on this line. When it's not a line, when you have a curve other than a line, it would be impossible without calculus to find what that instantaneous rate of change, what is that slope at a particular point? Because it's different in different places on the line. And so first we look at average rate of change. And so average rate of change we talked about this yesterday. I don't know why it's now doing that. Okay, so average rate of change is basically finding the slope between 2 points that are on the curve. And so just kind of like we were doing before, we can call a point x sub 1 comma y sub 1, maybe x sub 2, y sub 2. So to find the slope, this is equal to our change in y over our change in x. We talked about the symbols yesterday, that we could write that with a triangle or Greek letter delta y over delta x. Or we could write it as, with these points, right? We could write it as y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Other notation, so all meaning the exact same thing. What if it was in function notation instead of as a y? So f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. So if the function is continuous, on some interval, so I'm going to write that interval in interval notation. And so I'm putting a bracket here and then an a comma bracket b. So basically that's saying it's continuous from all the x values of a, including, all the way up to the x value of b, including. So if the function is continuous on some interval a, b, then we know the average rate of change. Well, the y value when x is b, right? We can write it as f of b in function notation. So f of b minus that y value when x is a, which is f of a. As long as we're consistent with what x value we use in the denominator, which was the same y value in the top. So this would be b minus a here. This is called the slope, or this is also the slope of our secant line. Okay, so let's look at an example of finding the equation of a secant line given the function and the values that we want to find it in between. Okay, so we're going to look at an example. We're going to find the average rate of change of the function f of x equals x cubed minus 2x over the interval bracket 1, 2. Correct. Okay, so let's first find the average rate of change. Let's say this is part A. So we need to find the 2 points. We know what our x value is. So this is telling me that x equals 1 and x equals 2. And so if I look at when x equals 1, let's figure out what the y value is. So we need to look at what is f of 1. So usually what I do is I kind of go through and I put in a parentheses wherever I see an x in my equation. So I see an x cubed, so I'm going to put parentheses, then I'm going to cube it. Minus 2, I see an x there, so I'm going to put a parentheses. And now I'm going to put inside those parentheses the value of x, which is 1. So we can use our order of operations to simplify. So we got exponents first. So 1 cubed is 1 minus multiplication first, 2. So 1 minus 2 gives us negative 1. So one of our points is 1, negative 1. And now let's look at when x is 2. And so again, we're just going to go in and wherever we see an x in our function, we're going to put a parentheses and then go back and replace that with a 2. So we have f of 2 is equal to, I see a parentheses, cube it, minus 2. I see an x, so put parentheses. That's what I meant to say. So order of operations, 2 cubed, which gives us 8, minus 2 times 2, which is 4, and 8 minus 4 is 4. So we got a point at 2, negative 4. I'm sorry, 2, positive 4. So we want to find the average rate of change between those 2 points. The change in y. So 4 minus a negative 1 all over 2 minus 1. Well, minus a negative is really plus. So 4 plus 1 is 5 all over 2 minus 1, which is 1. So we found that that slope of the tangent line in between those 2 points, or the average rate of change, is 5. Okay, so we want to remember what a slope is. We want to find the equation of a line. So to find an equational line, remember you need two things. And if you don't have those two things, you usually have enough information to get those. The slope, which we have, and at least 1 point, and we have 1 point. So point and the slope, we can find the equational line. So you can use your point slope formula. I tend to like to put it into the slope intercept form and just figure out what B is, my y-intercept, and then have it. But whatever way you want to do it will work. I'm going to get an extra page just so I have enough more work or more room. So part B, let's find the equation. The secant line. On the interval. One, two. So we had found slope was 5. And we have a point. One of them was 1, -1. So we can use y minus y sub 1 equals m all times x minus x sub 1. Or this would be our x sub 1 value. This would be our y sub 1 value. Or you can use y equals mx plus b. You can plug in what we know. We know what our y value is. Y is -1. So we have -1 is equal to our slope. So looking up there, our slope was 5. Times x. So looking at my x value is 1. Plus b. Now if I figure out what my y-intercept is, I know what my equation is. So let's solve for b. So I have -1 equals 5 plus b. Subtract 5 on both sides, I get b equals -6. So knowing b is -6, my slope is -5, I'm sorry, positive 5. You know, the equation of the secant line is y equals the slope, which is 5 times x plus b, so -6.